what was left, and God willing, we need to complete the course if all goes well. But if we don't, then we are likely to complete it next time. So we wish to look at where we left. And I remember we are looking at determinants, and we said that the determinant of a 2x2 matrix, this is the value obtained that describes the distance, which is obtained as the difference in the products of the elements in the main diagonal and those in the other diagonal or the secondary diagonal. Main diagonal means those that run from the top left to the bottom right, and the other diagonal is those that run from top right to bottom left. This is for 2x2 matrices, and we did examples like the ones I'm sharing. Matrix A, you got 11, matrix B, you got -68, matrix M, the determinant is 8. We went ahead and defined the determinant for 3x3 matrices, and we said that these are matrices obtained by reducing it to 2x2. And the method that we use, therefore, is what we call the Laplace method, or otherwise the cofactor method. So as we look at this, ladies and gentlemen, we follow a sequence that is given, this conventional, that the first term is always positive, the second negative, the third negative, if we are using the first row. We are going to see today on our chalkboard, how do we find the determinant of a 3x3 matrix, and how do we now proceed to get the general form of the Cramer's rule, and that will help us solve systems of linear equations that involve either 2x2 or 3x3. So by matrix inversion, we'll start with what you had looked at earlier and then proceed. So we wish to today be online, and we are going to use the chalkboard. So I wish that you be very careful and see what we are doing on the chalkboard. So we can switch so that you could see from the chalkboard what we are to do. So are you able to see me?
We are not seeing you.
You are not seeing me. So you ought to see me with the chalkboard.
No, sir. I'm not seeing you.
And share the screen first.
We are not seeing you.
We are struggling.
Open your eyes, because I know some of you are still sleeping.
We are struggling.
We are not seeing you, sir.
Yes. You will be seeing me in a short while.
Why?
Okay.
You are just sharing your screen.
Be patient as we log on, we connect. Be a little bit patient.
We are now seeing you.
No. No, sir.
Yes?
We are not seeing you.
Hello?
The lady was almost talking something. Do you want to talk?
We are not seeing you.
You are not seeing me.
Yes.
Yeah, true.
Even me, I'm not seeing you.
The chalkboard.
Mwalimu, we
So?
are not seeing you.
I'm looking
Hello?
for where you are. Where are you hiding? I want to see you.
Yeah, our house.
No, I want to see you as you see the chalkboard.
Nanisimamisha bwana.
Is it not the one that we are giving open and distance learning? Baby? Yeah. Are you able to see me now?
No.
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 No, we are not seeing you, Mwalimu.
It keeps on disappearing.
Okay, stop
You're
sharing.
Unless we
Or can we come physical class?
Yeah, and you sharing your screen.
Not seeing you.
So open your camera.
Are you able to see me?
No.
No.
Camera is shut.
Yes.
Stop sharing.
We
Can you
are
see me?
now seeing you.
Can you see the jumbo?
Yes.
But you keep on disappearing.
so the
I'm
problem
coming
is
and disappearing.
the problem
Mitambo inaandaliwa, so just be a little bit patient. You are not
Unazimika
stable.
unawa.
I'll be asking, what are you seeing on your screen?
We are now seeing you.
What are you seeing on the screen?
I'm seeing a board.
Just.
I can see a
Are you seeing me?
We are seeing you.
Yes.
Are you able to see me?
Yes.
Yes.
Hi.
Hi.
Hello.
Are you seeing my hand?
Yes, we are
Yes.
seeing.
What? Just your camera.
We are seeing your beard, your nose, your head.
You are
What
there.
am I doing?
Yes, you are right.
Lakini mkono imejificha huko.
I am
We are
waving.
seeing your humble
Yes.
face.
Kuona
Yeah,
stars.
then you can see me.
Hello.
Continue.
So we are talking of determinant, and the determinant we are defining to be the distance. So if I have a matrix defined as matrix A
I'm seeing
with the elements A, B, C, D, then the determinant of this matrix, which you can give as A in 2 bars, or we write this as det A. This is the difference in products of the elements in the main diagonal. What are the elements in the main diagonal? Those that run from the top left to bottom right. So the product of those elements are defined as AD minus those in the other diagonal, PC. That is what we are saying for 2 by 2 matrix. So if that's our 2 by 2 matrix, then how do we find the determinant? The determinant is the difference. So look at the following. Suppose I have a matrix, say matrix A defined as 3, 4, 1, 5. Then the determinant of A will be defined as the difference in products of those in the main diagonal, 3 times 5 minus those in the other diagonal, 4 times 1. And this gives you 15 minus 4, and that will be equal to 11. So 11 is actually what we refer to as the modulus, or otherwise the distance. Look at the matrix M, defined as 3, 2, 2, 4. Then the determinant of M, as we have said, is the product of the elements in the main diagonal, 3 times 4 minus 2 times 2, and this gives you 12 minus 4, and that will be equal to 8. That is what we said, and that is what we are doing for 2 by 2 matrices. Now, we look together the 2 by 2 and the 3 by 3. If I have a 3 by 3 matrix, what happens? So we can get this in a number of ways. That matrix A, I can get this, or also I can look at matrix A and define its determinant as the difference 3, 4, 1, 5, and this will give us 3 times 5 minus 4 times 1, and this will be equal to 15 minus 4, and that equals to 11. Presenting it this way and presenting it this way is one and the same thing. Let us now see, suppose it is a 3 by 3 matrix. If it is a 3 by 3 matrix, then we have our matrix A. 3 by 3 means is of order 3, and order 3 means 3 rows and 3 columns. So this will have the elements A, B, C, D, E, F, G, H, I. What did we say about this? That we can get the determinant of A by reducing this 3 by 3 to 2 by 2, because we know how to get the 2 by 2. How do we reduce? We delete a column by a row. Suppose I use row 1. We must understand that as we do this, we have the convention. The signs are, for row 1, positive, negative, positive. For row 2, they follow the order, negative, positive, negative. For row 3, positive, negative, positive. This is for 3 by 3. That if I'm using row 1, then I'll follow the sequence of signs. If I use row 2, I'll follow the sequence of signs. If I use row 3, I'll follow the sequence of signs. All this will give you one result. Suppose we use row 1. So we want to use row 1. So we are looking at row 1, column 1. What is the common term? The common term is A. A, but from our signs is positive. So this will be A. If I delete row 1, column 1, what am I left with? I'm left with this 2 by 2. E, F, H, I. When I do this, it means the determinant, the way we have reflected it here. Then the second one takes the negative, so it's minus because of that sequence. I am looking at row 2, column 2. The one I'm shading in blue, row 2, column 2. If we delete that, then the common element, row 2, column 2, gives us B as the common element. If I delete row 1, column 2, I'll be left with the DF, then GI. Then the third term takes the positive side. So it will be plus. Now I'm looking at row 1, column 3. Row 1, column 3, the common term is C. Then the reduced 2 by 2, if I delete row 1, column 3, I'll be left with D, E, G, H. So this is the reduced matrix. So by reducing this, I'm reducing to 2 by 2 and proceed therefore to get the determinant, because we know how to get the determinant of 2 by 2. For this case, therefore, this will reduce to A times EI minus FH minus B times DI minus FG plus C times DH minus EG. So if you evaluate this, then what you get is what we are referring to as the determinant of 3 by 3. Let us look at an example. Suppose we have the following example. 2, 1, 1, 1, negative 1, negative 2, 5, negative 2, negative 4. Assume this is our matrix A. Then determinant of A will be equal to. We want now to reduce this to 2 by 2. Using row 1, the common term for row 1, column 1, the common term is 2. If I delete row 1, column 1, I'll be left with minus 1, minus 2, minus 2, minus 4. Minus, because that's the order of our sequence, row 2, or column 2, row 1. The common term is 1. It's row 1, column 2. The common term is 1. So if I delete this and this, I'll have 1, minus 2, 5, minus 4. You have to be very keen today. Then the third term takes positive because I'm using row 1. So row 1, column 3, the common term is 1. Now if I delete row 1, column 3, I'm left with 1, negative 1, then 5, 2, negative 2. So we have to get this and evaluate. If you evaluate this, then you have 2 times negative 1 times negative 4, that gives you 4. Minus negative 2 times negative 2, that gives you 4. Minus 1. We have already this determinant. 1 by negative 4 is negative 4. Minus negative 2 by 5 is negative 10. Plus 1. 1 by negative 2 is negative 2. Minus negative 1 by 5 is negative 5. Evaluating this, you have 2, 4 by 0, 4 minus 4, that gives you 0. Minus 1. Negative 4 minus negative 10. This will give you negative 4 plus 10, and that gives you 6. Plus 1. Negative 2 minus negative 5. This is like minus 2 plus 5. That gives you 3. So you evaluate this, you have 0 minus 6 plus 3. And that will give you negative 3 as the determinant. That gives you negative 3 as the determinant. Let us look at this afresh. If I have a 3 by 3 matrix with the element A, B, C, D, E, F, G, H, I, then I can get the determinant of that 3 by 3 by the Laplace method, where I reduce this to 2 by 2 by deleting the appropriate row and column. If I use row 1, the first term is A. Deleting row 1, column 1 leaves me with E, F, H, I. The sequence of signs is given. Row 1, column 2, the common term is B. If I delete row 1, column 2, I'll be left with D, F, G, I. I reduce 2 by 2. Then the third term is plus. The common term in row 1, column 3 is C. Deleting row 1, column C leaves me with D, E, G, H. Then I evaluate that. And this is what we have applied in this example to get the determinant of the 2 by 2. That is what we are talking about. Could we look at the following as an example? Pia for example wafanye. One, two, 1, 0, 2, 4, 2, 4, 2, 5, 3. Evaluate the following determinants. For M, defined as 1, 2, 1, -1. The green one. Matrix N defined as -1, 0, 2, -4. Matrix B defined as 2, 1, 3, 4. Matrix X defined as 2, 1, 1, 1, -1, -2. Asi hii tumefanya. Hii tumefanya. 1, 1, 2, 1, 2, 1, 2, 1, 1. Find those determinants and share your results on the chat box. Share your results on the chat box. Do it quickly. Somebody's getting matrix N 4, matrix B 6. M is -3. N is 4B6, yes. N is 4B6, that's correct. M is -3, N is 4. Good for X. Check for X, check for X. You are getting different answers for X. The 3 by 3, some of you are getting -6, others are getting -4, others -7. Which is the correct answer? We can work out for X that's giving us different answers. This is equals to 1 reduced 2 by 2 is 2, 1, 1, 1 minus 1, row 1, column 2, 1, 1, 2, 1 plus 2, row 1, column 3, 1, 2, 2, 1. This gives you 1 times 2 minus 1, that's 1, minus 1, 1 minus 2, that's -1, plus 2, this is 1 minus 4, that gives you -3. So this will be equal to 1 plus 1 minus 6. So this will be equal to 2 minus 6, and that will be equal to -4. So the answer for X, the determinant for X is -4. Then before we look at application of this concept of matrix algebra of 2 by 2 and 3 by 3, let us define what we refer to as the inverse matrix. The inverse matrix. An inverse matrix is that matrix whose product with the initial matrix gives us an identity. Remember, we defined what an identity matrix is, and we said this is a matrix whose elements in the diagonal are all ones, and those in the other diagonal are zeros. So if I look at an identity matrix of order 2, then I have it in the form 1, 0, 0, 1. This is the identity matrix. If I have an identity matrix of order 3, then you take the form 1, 0, 0, 0, 1, 0, 0, 0, 1, such that the elements in the main diagonal are all zeros. Which is the main diagonal? This is the main diagonal for 2 by 2, the main diagonal for 3 by 3. This is all ones, and this is all ones. So a matrix that takes this form, this is what we refer to as an identity matrix. So if I have a matrix A, if I have a matrix A, then its inverse is noted as A raised to the power of -1. So the matrix A, its inverse is A raised to -1. And the general practice, the general rule of the term is that a matrix A times its inverse. This is the same as the inverse times the matrix A, and this is what gives you the identity. This is the general form, and that is the general rule of identity matrix. That a matrix multiplied by its inverse is equal to the inverse multiplied by the matrix, and which gives an identity. This is the only time. Remember what we saw last time about commutativity property. That the matrix AB, I don't know if you remember if it was equal to BA. Check. Was AB equal to BA? If AB equals to BA, then P is the inverse of matrix A. That's the rule. Otherwise, AB is not equal to BA. The multiplication is not commutative, unlike in addition, where we saw it was commutative. In subtraction, it was not commutative. So this is the thumb rule. If in multiplication AB is equals to BA, they are commutative, then those matrices are what we refer to as the inverse matrices. But how do we get the inverse of a matrix? There is a standard procedure of determining the inverse. For us to determine the inverse, we must first of all determine the determinant of that matrix. Determinant of the matrix. So this is the first step. If I have the matrix A, then I must determine the determinant of A, which we say is the same as det A. So always find the determinant of the matrix. And this determinant must not equal to 0. Why do we say so? If the determinant of A is 0, then that matrix has no inverse. You don't proceed. I repeat. The first step in finding the inverse of a matrix is to get the determinant of that matrix. We know how to get the determinant of 2 by 2 and the determinant of 3 by 3. So if we have already that determinant, the determinant must not be equal to 0. But if it is equal to 0, then that matrix has no inverse. What is the geometrical interpretation of a matrix whose determinant is 0? We are defining the same line. We are defining the same equation. The equation of the line, the equation of the same line gives us the determinant of 0. So if the determinant is 0, then the matrix has own inverse, you don't proceed to get the inverse. But if it is not equal to 0, then you proceed to step 2, which is interchange the elements in the main diagonal and reverse the signs of the elements in the other diagonal. Meaning, if I have the matrix A defined as A, B, C, D, and determinant of A, which is equals to AD minus BC, is not equal to 0. Then I interchange the elements in the main diagonal. If I interchange the elements in the main diagonal, in step 2, I have BA. Then reverse the signs of the elements in the diagonal. This will remain minus B. This becomes minus C. So this is the inversion. And then now proceed to get the determinant of that, the inverse of that matrix, as 1 all over the determinant times the inverted matrix. D minus B minus C, A. This is what we are saying. The procedure of inverse of 2 by 2, first evaluate the determinant. If the determinant is 0, then that matrix has no inverse. If the determinant is not equal to 0, proceed to step 2. Invert the elements in the main diagonal and reverse the signs of the elements in the other diagonal. Then proceed to determine the inverse by 1 over the determinant times that inverted matrix. This is a scalar. This is a matrix. We did scalar multiplication. So we use that knowledge of scalar multiplication. The scalar multiplying the matrix. It is not the matrix multiplying the scalar, it's the scalar multiplication, because 1 over the determinant is a scalar quantity. Recall how we define the scalar. This is what we do for 2 by 2. Look at the following examples. Tunakauka haraka haraka. Hiyo nini yako iko wapi? Spray hapa. Spray huku kwanza. Spray huku kama tunatumia huku. Hiyo duster pia ni chafu. Uzi nini? Tukitumia black.
Sawa, kama iko na wino sawa.
Hiyo haitakuwa inahitaji kupanguza.
Iko na kalamu na tablet.
Hii naona sasa dalili ya kumaliza hiki. Imebaki application. Somebody is saying the pressure increases. Which pressure? Tuanzie hapo. Hii yako hii. Yako pia ni sawa. Na hii yangu. Iko tu sawa, black ziko sawa. Let us look at the following. Suppose you have the matrix A defined as 2, 1, 3, 4. Then the determinant of A is equals to 2 times 4 minus 1 times 3. This gives you 8 minus 3, and this gives you 5. And therefore, the inverse of A is 1 all over 5, which is 1 over the determinant, times the inverted matrix. 2, 4 becomes 4, 2. 1, 3 becomes -1, -3, which we have said gives us the inverse matrix. It's not being seen, or it's not clear. Now, so if we do this, The scalar multiplication, recall we said that the scalar multiplies each element. So 1/5 times 4, that gives us 4/5. 1/5 times -1/5, that gives us -1/5. 1/5 times -3, that gives you -3/5. 1/5 times 2, that gives you 2/5. And this is now the inverse of that matrix. That is the inverse of that matrix. Look at the following. Suppose I have the matrix M defined as 3, 4, 1, 5. Then determinant of M, we did it and we got it as 3 times 5 minus 4 times 1, and this gives us 8 minus 4, and that 15, sorry. 15 minus 4, and that gives us 11. Then M inverse would be equal to 1/11 times. We invert the elements in the main diagonal, is 3, 5, so that becomes 5, 3. Then reverse the signs in the other elements, minus 4, minus 1. So this becomes the scalar multiple. So you multiply this to get the inverse as 5/11, minus 4/11, minus 1/11, then 3/11, and this becomes the inverse. To confirm that this is the A inverse, you can find A inverse or A inverse A. And all these must give you an identity of order 2. Similarly for matrix M, find M times M inverse. This must be the same as M inverse times M, and that should give you an identity of order 2. This is what we are talking about. And for us now to see this, then we can proceed to solve systems of linear equations that involve two unknowns. We can use this matrix method, the inverse method, to solve linear equations. For example, if I have two linear equations as ax plus by, this is equals to s, and cx plus dy, this is equals to t. This is a system of linear equations that has two unknowns, and the unknowns, the variables here are in x and the values in y. A and c are the coefficients of x, b and d are the coefficients of y, s and t are the constants. So we can extract from the knowledge of matrix algebra the following three matrices. We can extract the coefficients for this A, then C. We can extract those coefficients in Y, B, D, and if I write this a matrix algebra XY, so that remember from multiplication, A times X, so this one should not be there. A, B, C, D. So that if I get this product, A times X to give me AX, plus B times Y to give me BY, C by X to give me CX, D by Y to give me DY. This is what gives us the constants ST. So for us to solve this, we must reduce the left-hand side so that we only have the unknowns. This is the standard, that if we do this, we call this the matrix of coefficients. This one is the matrix of unknowns, and this one is the matrix of constants, or the resultant matrix, depending on which book you are reading. So we can look at this and then apply the inverse method, which means we reduce the left-hand side to an identity, so that is with unknowns. And what we do to the left-hand side, we also do to the right-hand side. This is what we are saying. So we get the determinant of the coefficient matrix, the inverse. Then we multiply through the left-hand side and the right-hand side. Then proceed to evaluate to get the knowns. For example, x plus 2y, this equals to 7. X minus y, this equals to 1. We have two systems of linear equations with two unknowns. Extracting the matrix equations, we shall have the coefficient of x as 1, 1. The coefficient of y as 2, -1. This is -1. Then x, y. And this gives you 7, 1. Evaluating the coefficient matrix, we need the determinant of 1, 2, 1, -1. And this gives you, this times this is -1 minus this times this is 3, and that gives you -3. That's the determinant. And therefore, the inverse would be equal to, we interchange the elements in the main diagonal. It's 1 all over the determinant. That's now 1 over -3 to give us -1/3 times. Interchange the elements in the main diagonal. This 1, -1, so that's -1, 1. Then reverse the signs of the elements that are diagonal. This 2, 1, so it becomes -2, -1. You evaluate this, you get the determinant. Now, what did we do to our main equation? We pre-multiply through by the inverse. Meaning, we multiply this inverse on the left and the inverse on the right to give us -1 over 3 times -1, -2, -1, 1 times the left-hand side, which is 1, 2, 1, -1 times x, y. This is equals to the inverse. We are pre-multiplying. We start with the inverse. -1 over 3 times -1, -2, -1, 1 times the constants 7, 1. Evaluate this and see what you get. Evaluate this and see what you get on the left-hand side. Evaluate that. Ndakuwapea alternative. Cramer suruli ya 2 by 2. Your 3 by 3 and we cross. If you evaluate this, I hope you are getting 1, 0, 0, 1 times x, y. Evaluate the right-hand side. Quickly, this will give you -1/3 times -1 by 7, that gives you -7, plus -2 by 1, that gives you -2, and that gives you -9. Row 1, column 1, -1 by 7, that gives you -7, plus 1 by 1, that gives you +1, -7 plus 1, that gives you -6. Evaluating this, negative a third times negative 9, that gives you 3. Negative a third by 6, that gives you 2. If you evaluate this is an identity, so it gives you x, y, and this gives you 3, 2. X, y, then 3, 2. But from the knowledge of equal matrices, the way we define, two matrices are said to be equal if they are of the same order. This is 2 by 1, this is 2 by 1. And if they are equal, then their corresponding elements are also equal, and therefore x is equals to 3 and y is equals to 2. So the solution to a matrix, x plus 2y is equals to 7 and x minus y is equals to 1, by inversion gives us x is 3, y is 2. That is what we are saying. That is what we are saying. Now look at the following. Example 2. 2x plus y is equals to 4. 3x plus 4y is equals to 1. Extract the system of matrices as 2, 3, 1, 4, x, y. This is 4, 1. The determinant of 2, 1, 3, 4, this is 8 minus 3, that gives you 5. And therefore, the inverse will be equal to 1 over 5 times the inverted matrix, that is 4, 2, then negative 1, negative 3. That's the inverse. Pre-multiplying through the matrix equation is 1 over 5 by 4, negative 1, negative 3, 2. Multiplying the left-hand side, 2, 1, 3, 4, x, y. This gives you the inverse, 1 over 5 by 4, negative 1, negative 3, 2, multiplying the constants, 4, 1. If you work out this, the entire of all these will give you 1, 0, 0, 1. X, y. The right-hand side will give you 1 over 5 times 4 by 4 is 16. Plus negative 1 by 1 is negative 1. So that gives you 15. Negative 3 by 4 gives you negative 12. Plus 2 by 1, that gives you 2. Minus 12 plus 2, that gives you 10. And therefore, x, y is equals to 3, 2. Meaning that x is 3, y is 2. X is 3, y is 2. I don't know why this is giving us the same results, but it doesn't mean that always x is 3 and y is 2. That is what we are saying, and that is what the inverse matrix is all about. We can use the inverse matrix to solve systems of linear equations, and that is given by the two examples. Now, we can use Cramer's rule to also solve these systems of linear equations for 2 by 2 and extend it to 3 by 3. That's if we use the example 2, which we have as 2x plus y is equals to 4, 3x plus 4y is equals to 1. We extracted the system of matrix equations as 2, 1, 3, 4, x, y, then 4, 1. Now we talked of Laplace method. Perhaps I explained this before we proceed to look at that example for us to understand well what the Laplace and how it works. If I have a matrix, AX plus BY, this is S, CX plus DY, this is T, with the system of matrices as A, B, C, D, then XY is equals to ST. We said that we can find the determinant of the coefficient matrix denoted as A, B, C, D. With Cramer's rule, if I want to solve for X, I must replace the coefficients of X by the constants. Then divide that by the determinant of the initial matrix. Now, if I do that, the determinant of X are AC. The coefficients of X are AC. So I replace them by the constants ST. So I get the determinant of ST. Pay more attention. We are replacing only the coefficients of X, which is AC, by the constants ST in our coefficient matrix. And the rest remain B, D. So if I get that determinant, I divide by the initial determinant of the coefficient matrix A, B, C, D. That will give me the value of X. Meaning, I can also find the value of Y by substituting the coefficients of Y and dividing by getting the determinant, which I divide by the determinant of the coefficient matrix. So Y will be equal to coefficients of X remain AC, and those of Y take the constants ST, divided by the coefficient matrix A, determinant A, B, C, D. That is what we call by Laplace method, or otherwise what we are referring to as the Cramer's rule. That is the Cramer's rule. So this is starting from 2 by 2. So we can use this to solve our other systems. We have worked out this and we've got the solutions. So are we able also to work out so that we get the same results? Yes. Let us use the Cramer's rule, which means that the value of X is obtained by what is the determinant upon replacing the value of X. The value of X here is 2, 3. So I replace by the constants 4, 1. Those of Y remain 1, 4. Divide by the determinant of the coefficient matrix 2, 1, 3, 4. And this gives you, this is 4 by 4, 16 minus 1 by 1 is 1. So this gives you 16 minus 1 all over. 2 by 4 is 8 minus 1 by 3, that is 3, so minus 3, and this gives you 15 all over 5, and that is equals to 3. As simple as that. We do the same for Y. For Y, we replace the coefficients of Y in our equation. So those of X remain 2, 3. Those of Y take the constants 4, 1. Divide this by the coefficient of the determinant matrix 2, 1, 3, 4. And this gives you 2 by 1 is 2, minus 4 by 3 is 12. Divide this by the coefficient determinant matrix. 2 by 4 is 8, minus 1 by 3 is 3. So this gives us minus 10 all over 5, and that gives you negative 2. Now the other one, we got it as a 2. And this one is giving us negative 2. We can check and see. Because here we got Y as 2, but with the Cramer we are getting Y as negative 2. So we can check that and see what or where we have gone wrong. That is how to evaluate by Cramer's rule. Now that This is for 2 by 2. We can extend the same concept of determinants to 3 by 3. Using the same Cramer's rule, we can now apply to 3 by 3. How do we do that? Or what is the general format for Cramer's rule for 3 by 3? So the general format follows that of 2 by 2 that we have seen. If I have a system of linear equations, 3 equations in 3 unknowns, I have ax plus by plus cz is equals to r. Then dx plus ef plus abcde, this ey, de, then f, z is equals to s. Then I have gx, hy, iz is equals to t. The unknowns here are clear. X, y, z. With the coefficients for x as a, b, c, for y as b, e, h, and for z as c, f, I. And this will therefore be the constants. So we can extract the system of matrix equation as that of coefficients a, b, c, d, e, f, g, h, I. That of unknowns as x, y, z, because these are in unknowns, then r, s, t as constants. So we know this is the coefficient matrix. This is the unknowns. And this is the constants. So solving for x, y, and z follows from what we have done in 2 by 2. So if I am solving for x, this will be equal to, I substitute the coefficients of x by the constants to have r, s, t. Those of y remains b, e, h. Those in z remains c, f, I. That determinant divided by, if I write it like this, note that that's the determinant. So by the determinant of the coefficient matrix, a, b, c, d, e, f, g, h, I. That will give us x. For y, we substitute the coefficients of y in our coefficient matrix. So for x remains as a, d, g. Then y is what we are solving, gets the constants r, s, t. Then for z remains c, f, I. Divide this by the determinant of the coefficient matrix, which is a, b, c, d, e, f, g, h, I. When I do like that, these are determinants, remember the way we had said. Then finally, for z, we are substituting the coefficient of z. So these are c, f, I. So that's what we shall substitute. So for x and y remains as a, b, g, then b, e, h. Then those for y take r, s, t. Divide this by the coefficient, determinant of the coefficient matrix, which is a, b, c, d, e, f, g, h, I. Evaluating this gives us the solutions, and this is by what we call the Cramer's rule. As simple as that. So we look at an example. Okay. In the first equation, by use of determinant y is -2. How do we calculate the inverse of a 3 by 3 matrix? That's above there. We will answer that. We will answer that. Udiani anza lini? Bado tuko na time. 11 next week, this week Friday. I'm avoiding mathematics. That's my only problem. Mbona una shout mimi nimegwama for the first method. So look at the following. 2x plus y plus z, this is 4. X minus y minus 2z, this is 0. And 5x minus 2y minus 4z, this is 3. Extract the system of matrix equation as step 1. Extract the system of matrix equations as step 1. Extract such a system of matrix equation as step 1, so that we know the coefficient matrix, the matrix of unknowns, and the matrix of constants. So this will be 2, 1, 1, 1, negative 1, negative 2, 5, negative 2, negative 4. X, Y, Z. Then this gives you 4, 0, 3. So we want to solve for the unknowns. So we start by Cramer's rule, we solve for X. For X, the coefficient matrix we substitute by the constants. So that's 4, 0, 3. Y remains 1, negative 1, negative 2. Z remains 1, negative 2, negative 4. Divide this by the determinant of 2, 1, 1, 1, negative 1, negative 2, 5, negative 2, negative 4. Find that determinant. We know how to find the determinant of 3 by 3. We reduce it to 2 by 2 and proceed. For y, we substitute the coefficients of y. The x remain 2, 1, 5. Y take the constants 4, 0, 3. Z remain 1 minus 2 minus 4. Divide this by the coefficient matrix determinant 2, 1, 1. 1, negative 1, negative 2, 5, negative 2, negative 4. Then finally, we find for Z, we substitute the coefficients of Z by the constants. So the X remain 2, 1, 5. The Y remain 1, minus 1, minus 2. Then we substitute for Z 4, 0, 3. Divide by the coefficient 2, 1, 1, 1, negative 1, negative 2, then 5, negative 2, 5, negative 2, negative 4. Let us find those values and share on the chat box, because we have been looking at the determinant of 3 by 3. We looked at it and we can see that if it can help us solve the systems of linear equations. Work out that and share on the chat box. Doc, I accidentally enrolled the unit. After enrolling it again, I didn't get the cut marks in the portal. How can I go for it? Hakuna. Cramer has already best. I wondered in Herkoman's high school. Reading the chat box. Unapotea wapi? Regroup yourself. The board is not clear. I think we have cleaned it. It's now clear. Unapotea wapi? The board is clear. Ama? Which question do you want to explain, Okumu? We are solving for the unknowns. Go online error code. Somebody has gotten X as 1. X is -3, Y is 3, Z is -1. Why are you getting different answers? Hello? Right. Hiyo wanaweza fanya. Let us conclude. Can you look at the exercise so provided? Look at the exercise so provided. Use Cramer's rule, then compare the results. Use Cramer's rule to solve those systems of linear equations, A, B, and C. Use Cramer's rule. Please have those as exercises. Doc, always you give exercises, we do, but you never ask for it. Why? It's for your own practice. When I give you for your own practice. Repeat the exercise. Yes, it is there. I've repeated. What about the inverse of 3 by 3? That's a long process. I don't intend to teach that one. Because from the determinant, we go to the cofactor matrix, the matrix of minors, the adjoint matrix. That's a very long procedure. So I've left that one out for this case. Any other issue you are raising? Boniface Nyongesa, I don't know what X is 0, Y is 0, Y Z is 0, I don't know. You need help? Yes, I'm there for you. Look for me. Share the notes on the e-learning portal. Yes, the notes are there. And I think we'll also share all the lessons that we have had in this course. I'll ask the technician to share with you on WhatsApp all the lessons that we have had in the previous years. That will give you enough exercise. The lectures still there or imeisha leo, I don't know. Sudu, unapatikana wapi? My office number is ABB 214. This thing is moving so fast. So you get me in ABB 214, I'm going to that office right away. The concept of dividing X with the determinant, imenipita kidogo. We don't divide X by the determinant. I don't know what you mean. You can consult me or consult your friends. So dogo, kwa exam utaseti gani nijipange nayo tafadhali. I don't leak exams. The exam will come from the course. What I've taught. Lectures still there or imeisha leo, I don't know. I need your help, I've said. Share the notes, I've said. Need help, I've said. 3 by 3 inverse, I've said. But I've realized some of you, when I talk things here, you are not keen. We are not able to download the notes, sir. Seek help from Odell. Fine, thank you. Kibet, that's fine. Well, sir, you resemble Ruto. I don't care, me, I'm a Bukusu, I'm not a Ruto. Unaweza nisaidia maka pen. Unaweza kujia. If you have not understood DM, have enjoyed the class, kindly tell us. Because we are starting exams on Friday. I tell you what, I finished the course today. Thank you for the lecture. You are the best. Thank you. Multiplying this 3 by 3. Enjoy, enjoy, enjoy. So, we are working out those who missed either cut 1 or cut 2 will give a supplementary cut on Thursday morning. Nasema hivi mwingine atakuja anaanza kuniambia ati notice ilisema at 5 p.m. Nakuuliza toa hiyo notice, unaanza kujikuna kwa kichwa. Upumbavu ya watoto na mchezo yenu hiyo sitaki. I'll give a makeup cut for only those who missed. If you do it and you have the 2 cut marks, I'll give you 0. Am I clear? Okay, on. Unmute them. I want to be very clear on this, and everybody should get it right. I don't entertain excuses. For those who gave sufficient reasons to miss the cut will be there on Thursday morning.
Thank you.
For those who I have told I will give. But if I have not told you, it means you have not convinced me. Ambe kukosa tu kufanya mtihani mnafanya vitu zenu alafu mnakuja hapa ati the notice was 5 p.m. Mnakuja toa hiyo notice because I also have the notice. Niseme mnafanya huko pia kama Radio Citizen or Milele FM. You do jokes and I'm making very serious announcements. In the cut, prepare well. In the exam, usibebe mwa Kenya. You may carry a calculator. Phones will not be used. Hakuna simu itakuparika. Ukipatikana unakwenda kwenu. Wewe sema tunatoa vitisho mingi. Utajua ujui, uliza wenye nimefundisha.
Hatuna calculator.
Kopi mtihani. Your calculator must be clean, usiandika hapa hata formula peke yake. Fanya tu sema hivi na mnafanya vitu yenu. Unaenda kwenu. Usiseme nilikuwa natoa vitisho. That time is when you realize. Don't give me an excuse ukishikwa na Mwakenya. However small it might be. Not even a formula only. Nasema come there.
Hello, table.
And the calculator on, not the phone. I've said that.
Hey!
Kama nasema vitisho. Mtajua mjui.
Mwalimu.
Questions?
Hakuna mwalimu wakati submit.
Hakuna. I'm waiting for questions.
Mwalimu.
Yes.
Nini kati lijisubmit ile time na sikuwa nimemaliza. Naweza rudia hii.
Namna gani? You are copying?
No.
Don't tell me no. You are copying. The system was set 1 minute per question. It stays idle.
Network ndio ilikuwa shida.
Bizi nakwambia unapingana. Pingana, enda pingana huko na watu rika yako.
Hey,
Wejipange.
Log in. The card will be on in the system online. Thursday from 9.
For those who did,
I repeat, for those who have agreed and missed cut 1 or cut 2. Fanya na nipata una cut 1 tena una cut 2 na ukuwe na hiyo makeup cut, utapata sufuri.
zero.
That one I promise and I want to swear, I'll give you 0.
Habakuka barakosa zero.
Those talking their mother tongue here, thinking that because I'm they can talk Lubukusu. You are wanted on my list. Fanya uone.
Lubukusu.
Class talking mother tongue. This is not a mother tongue class.
National anthem.
I've marked you already. I can see from where I am those who are talking and speaking their mother tongue.
Yeah, addiction.
I deal just with you circumferentially. You female students, you are very troublesome. I've said the cut is at 9. Kuja wanza kuniambia ati ilisemekana kuwa ni saa 4. Saa 4 itakuwa imejifunga. Kuja wanza kuniambia you thought it was at 5. Nani atakuwa amekwambia the cut is at 5?
Mambo mbaya.
Ati nani hao watapewa 0? If you qualify, I'll give you. If you deserve an A, I'll give you an A.
Kwa hiyo mbili sasa mtatumia gani?
Kwa hiyo
Kama una swali ya mahakama tu.
I'll average 2 cuts.
If I get an A and I missed a cut,
That's an incomplete mark. I cannot compute your results. For you to qualify to sit for the exam, enter some rules. You must have continuous assessment.
Na kama ulifanya cut moja.
Nasema kama ulifanya moja, ya pili ike nakuja makeup cut kama nilikubali inakuja on Thursday at 9. So you must have 2, not 1.
Okay.
The rules for exams are very clear. If you will only have cut mark by end of Thursday, you got a moja incomplete. You don't qualify to the exam.
Saa 3 asubuhi.
Wewe wacha kusumbua. Umesema saa ngapi?
Bado unafunza.
Simtumie tu ya kat mingi bwana.
Wewe saa.
Naongoja maswali.
Hiyo nauliza. Nauliza hiyo exam itakuwa calculation pure ama itakuwa na theory.
Talking about exam, question 1 is compulsory, touches all parts of the course. Question 2, 3, 4, and 5, you choose any 2.
Alafu.
Soma instructions vizuri.
Not French mtu nani?
Kelele mimi niko side manzi.
Here, one at a time. Who is talking?
Weka question 1 iko theory ba.
Question 1 is compulsory, touches every part of the course, the whole course.
wewe sasa tu mitihani mtu asikwambia.
5,
Sawa, itakuwa ngumu. Tuone room.
Inflation.
Hiyo makeup cut kufanyia room gani?
Mathematics exercise.
Section B kwetu na calculate.
Kuuliza maswali ya ujinga. Nasema cut is only 9 AM on Thursday. The whole course.
Ndio acha maswali.
So that is a makeup cut or for those
Cut 1
or
or
for
cut
everyone?
2. Stop confusing people.
Kama amefunga hapa ndio nani?
Is it possible? Mtu anauliza hapa, is it possible for what?
3 by 3 ama?
I'll deal with them.
Funga bando na bana.
Answer the question. If the choice is yours to do the questions or not to do, it's not mine. I've given instructions.
Mimi kuna nani sasa kufunga?
Compulsory. You do it and leave it, no problem. It's not my business.
Watu wa maswali.
Degree ni yako sio yangu.
Kuka hapa kuna nani sasa kufunga?
Shauri yenu.
Hapo kote na kuna nani?
At that time, therefore, I want to thank you so much for being my students. I want to thank you for attending classes, for those who consistently attended. I want to forgive those who are stubborn. I want to forgive them from my heart.
Thank you.
And I want to wish you
For them.
success in exams. Thank you so much. The class is adjourned until when we meet in second year and third year.
Give it a second.
Thank you so much.
Sawa.
Bye.
Duncan. Sawa. Lakini ngulula kwa sukuma.
Goza ba.
Okay. Dera wako kwa
Dera kuja sukuma sasa. Mwana. Mwana dera kuja sukuma sasa.
numbers. How are you?
Doctor.
Wakakuleta kinyororo.
Doctor.
Just need to be tough and arrogant in school.
Doctor.
Wanawake tomba.
Dr. Dan.
Question.